Hello students, today we will learn about factoring polynomials of degrees greater than 2. Remember, last time we looked at identities of quadratic polynomials. We looked at 3 identities. In number 1, we looked at a plus b squared is equal to a squared plus 2ab plus b squared. In number 2, we looked at a minus b squared is equal to a squared minus 2ab plus b squared. And we said that these two are called perfect squares. In number 3, we looked at a plus b into a minus b. It is equal to a squared minus b squared. And we called this the difference of squares. Today, we will look at the sum of cubes and the difference of cubes. When we talk about cubes, we actually mean the power of 3. So we begin with the difference of cubes. A cubed minus b cubed. So let us begin with an investigation. In number 1, factorize a cubed plus a squared b plus ab squared. Now, for this one, we can see that we have a in every monomial. Okay? So, we see that a, this is a, this is a, this is a. So, a is the common factor. So, I can write a and open the brackets. Now, for this a cubed, I already have 1a. I will remain with a squared. Okay, then I get to this one. I have a squared. I already have a here, so I say plus a. Then I say b plus this a here. I already have a outside, so I don't write it. I say b squared. So this means that a times a is a cubed. A times a is a cubed. Then a times a, that is a squared. Then and b. Then a times b squared, I'll get a b squared, which takes me back to this one. Okay, so this means that here we have a into a squared plus ab plus b squared. Okay, in number 2, we have got a squared plus b plus ab squared plus b cubed. So you see we have b, we have b, we have b. So let us put b outside the brackets. So we say b into, so this b is already here, so we write a squared. B into a squared plus a, okay, then b, it is b squared, but already we have 1b here, so here we write 1b, okay, plus b cubed, already we have this b, so here we have b squared. Okay, so you see that b times a squared, we get a squared b. Then b times ab, we get ab squared. then b times b squared, we get b cubed. So you say that here we have got b into a squared plus ab plus b squared. Okay? In number 3, let us find a cubed minus b cubed by subtracting. Subtract means minus. By subtracting the answer in number 2 from the answer in number 1. Remember, this is answer number 2 and this is answer number 1. So we get answer number 1 minus answer number 2. So this means that we get a cubed minus b cubed equals answer number 1, this one. This is answer number 1. So answer number 1 is a into a squared plus ab plus b squared. Then minus answer number 2. This is answer number 2. Okay? So we get b into a squared plus ab plus b squared. Okay? Now, by doing that, you see that this is a squared plus ab plus b squared. It is actually the same as this one. A squared plus ab plus b squared. So, what we do, we will get this a minus this b. So we get a minus b into the whole of this one, since they are the same. A squared plus ab plus b squared. So this means that if we have a cubed minus b cubed, we will get a minus b into a squared plus ab plus b squared. Let us check whether what we are talking about is correct. So we will get a times a squared. A times a squared, that will be a cubed. Again we get a times ab. That one will be a squared b. Then again we get a times b squared. We get a b squared. Then we get minus b times a squared. We will get minus a squared b. Okay? Then we get minus b times ab. We will get minus a b squared. Then we get minus b times b squared. That will be minus b cubed. Okay? Now, you see that a squared b will go with minus a squared b. That will go away. Then ab squared will go with minus ab squared, because we will get a 0. And finally, we get a cubed, which is this one, minus b cubed, which is this one. So you see that what we are talking about is correct. Okay? So This is what we call the difference of cubes. So that is an important identity when we are factorizing polynomials with degrees greater than 2. Now, let us talk about the sum of cubes. A cubed plus b cubed. And we begin our investigation. In number 1, we need to factorize a cubed minus a squared b plus ab squared. For that case, we see that this is a, and this is a. So a is a common factor. We write a and we open the brackets. So now, this is a cubed. Here we already have a. So we write a squared, such that this times this will give me a cubed, which is this one. Okay? Then minus a squared. A squared, we already have a. So I will write a, then b. You see that? Such that a and minus ab will give me minus a squared b, which is this one. Then plus ab squared. Ab squared, already we have a. So I will write b squared, such that a and b squared will give me ab squared, which is this one. Okay? So this is our factorization. You understand? Next, let us factorize a squared b minus ab squared plus b cubed. You see that we have b, and we have b. So b is the common factor. So we write b and open the brackets. Now we need to write this one, a squared b. So I write a squared. But already I have b here, such that you will see that a squared and b will give me a squared b, which is this one. You see? Then minus ab squared. Ab squared, I already have 1b. So I will have ab, such that b and ab, I'll get minus ab squared, which is this one. You see? Then plus, we have b cubed, but already we have 1b here. So here we have b squared, such that this b and this b squared, it will be b cubed. So you see, a squared b minus ab squared plus b cubed is equal to b into a squared minus ab plus b squared. Okay? So, let us move on and we get to number 3. We need to know a cubed plus b cubed by adding adding means plus. The answer in 1 to answer in 2. Remember, this is answer in number 1 and this is answer in number 2. So we will add them together. So in that case, we will say that a cubed plus b cubed is equal to answer in 1, this one. Answer in 1, that is a into a squared minus ab plus b squared, plus answer in b. Answer in b is this one, which is b into a squared minus ab plus b squared. Okay? Now you can see that actually this one is the same as this one. Okay? So once we add them together, we will simply get this a plus this b. So I get a plus b into this one. Remember, this one is the same as this one. So into a squared minus ab plus b squared. So that becomes what we call the sum of cubes. However, we can check. If I have a plus b into a squared minus ab plus b squared, which is actually this one, do I get a cubed plus b cubed? Yes or no? Let us check. If I get a times a squared, I'll come up with a cubed. If I get a times minus ab, I will get minus a squared b. And if I get a times b squared, I will get a b squared. Okay? And now I get b times a squared. That one will give me a squared b. Then I get b times minus ab, I'll get minus a b squared. Then I get b times b squared to get plus b cubed. And by doing that, we see that minus a squared b plus a squared b, this will give us 0. Then plus ab squared minus ab squared, this will give us 0. So we remain with a cubed plus b cubed. So it means that we have got a cubed plus b cubed. And this is what we call the sum of cubes. The sum of cubes. So we can conclude that the sum of cubes, if I have a cubed plus b cubed, I'll get a plus b into a squared minus ab plus b squared. And if I get the difference of cubes, that is a cubed minus b cubed, I'll get a minus b into a squared plus ab plus b squared. So student, in the next lesson, we shall see how can we apply the sum of cubes and the difference of cubes to factorize polynomials of degrees greater than 2. Thanks for watching. Now I want you to go to page 64 of your textbook and complete that part of investigation. Page 64 to page 65. Thank you so much. Please send your answers to me. Goodbye.